So good afternoon, everyone. I welcome you all to this 13th monthly HBNI webinar. I welcome our alumni speaker, Dr. Amit Chandrakar, Dean Academics and Associate and Assistant Deans of HBNI, who are offline and online. All participants, students and faculties offline and online. Ladies and gentlemen. This webinar series is designed to help the present students of HBNI in their placement and their career pathway. We are very much thankful to our esteemed alumni speaker, Dr. Amit Chandrakar, who has agreed to give a talk for our students. Thank you very much, Dr. Amit. I now briefly introduce our speaker. Dr. Amit Chandrakar is an alumnus of Homi Bhabha National Institute, HBNI. He obtained his PhD in Engineering Sciences, Mechanical Engineering from Bhabha Atomic Research Center in the year of 2015. He completed his B in Mechanical Engineering from NIT Raipur and MTech in Reliability from IIT Bombay. After completing his PhD, he has acquired extensive experience in industry, worked as reliability engineer in Eaton Technology Private Limited, Pune, senior analytics engineer in General Electric, lead data analytics in Airbus India. He is also DFSS Green Belt certified by Eaton Quality Institute. Currently, he is serving as principal data scientist in Symphony Incubator Business Service Private Limited. At Symphony AI, he is at the forefront of the industrial transformation, spearheading APM 360 for multiple steel and aluminum rolling plants. He is in charge of program management and technical leader to drive the implementation of cutting-edge predictive models that harness the power of AI to enable predictive maintenance. So let me now invite our alumni speaker, Dr. Amit Chandrakar, for his talk. We'll talk about AI and machine learning application and future scope in industrial domain. I encourage all the students and participants ask questions and engage with our speaker. Over to Dr. Amit Chandrakar.
Thank you, ma'am. I'll just share my screen and we'll get started. Okay.
Hi.
I hope, can you confirm if you can see my screen?
Yeah. Now you
Okay.
can see the screen.
All right. Okay. All right. So thank you for the generous introduction about me, ma'am, Dipamita ma'am, and I am really happy to present the topic on AI machine learning and their applications and future scope in industrial domain. I'm Dr. Amit, and I think ma'am has introduced me well, so I will not introduce me again. I have just few words to say that my time at HBNI was good. I have been at Hall 3 and Hall 7 at Reactor Engineering Division. Dr. A.K. Nayak was my guide, and Dr. Gopika Vinod was my co-guide. And I have spent almost 4 years at Homi Bhabha National Institute at PRC, and it was really very enriching, soul enriching um, in terms of knowledge, in terms of the work culture, and also everything around us was really great, right? I think ma'am has explained about my background. I have got mostly data science, artificial intelligence, and reliability as my background. I am a mechanical engineer. So yeah, with that, I'll go to the next slide and we will start our journey on AI and machine learning, right? Yeah, so I think before we begin, I just wanted to give a little bit more detail about the work that I'm doing at Symphony Industrial AI. You may not be aware of the company. So this is a software enterprise, software as a services company. We have products and services in retail, CPG, financial, industrial, enterprise, IT, media, right? So all of these domains, we serve or provide the services based on the AI and the machine learning. So that is why I have chosen this topic, and I'll take you guys through the journey of the AI and machine learning as well. So uh, I'll quickly introduce what exactly we mean by AI and the machine learning, right? So I think these terms, AI and the machine learning, they are in many times interchangeably used. But people often get confused what exactly is the artificial intelligence and what exactly is the machine learning, because these two are not exactly the same thing. So if I talk about machine learning, so machine learning is a type of artificial intelligence that performs data analysis tasks without explicit instructions. So ML technology can process large quantities of data, historical data. It can identify trends. It can predict the new relationships using the data that was previously unknown. You can perform various tasks. For example, you can do classification, you can do prediction, you can do all of these tasks on documents, on images, on numbers, and many different type of data sets, right? Whereas artificial intelligence, or also known as AI in short, is a technology which is like a human-like problem-solving capabilities. AI in action actually can simulate the human intelligence. It can recognize images. It can write documents. It can write even poems. It can make data predictions as well. But at this stage, I would say the data predictions, database predictions or forecastings are not really up to mark with the current LLMs or the artificial intelligence tools that you see. We are actually using machine learning more for the database predictions and AI for the tasks, for example, completing the complex tasks like chatbots, smart assistants, expert systems, robotics. These are main focus of the artificial intelligence. Whereas the machine learning we use for predictions and forecasting and classifications, right? So more of a scientific one. On methods that we use for artificial intelligence, right? So we use neural networks, computer vision, and generative AI, which are large language models or fundamental models. In machine learning, we generally use the supervised, unsupervised reinforcement learning. And there are a lot of algorithms, so I mean, starting from the um, least squares estimates, linear regressions, KNN, and k-means, and so on, right? The implementation of AI is actually done through the API. So we don't really do uh, full training of the large language models. We usually assess these models through the APIs, but for the machine learning models, we generally train our models which are very specific to the tasks, right? And that is why the accuracies of machine learning on the data predictions are really good. Whereas the AI is more suitable for the tasks which are more on the natural language processes, right? So all of these applications, if you see, right, are actually coming from one factor, which is the data, right? So data is the critical driving force behind business decision makings. If you see the modern organizations, right, they generate data from thousands of different sources, including smart sensors, customer portals, social media, and application logs. So we have like tons of data. And over the time, what has happened is that the compute cost has drastically reduced, right? So with the advent of the compute cost reducing and increasing the volume of the data, what we can see here is that how these models, right, the models perform when we have large amount of data. So when we have small amount of data, usually the simple statistical learning methods outperform any of the advanced models. So when we have smaller data set, we must always think of the simpler models and use them. When when the data volume increases, actually, if you see here, we reach a plateau, and these models really don't improve on accuracies, right? And they are also fail in fitting the large amount of data. So that is where the machine learning models comes in, which are the traditional machine learning models, right? They have the superior model performance when the data size is moderate or high. Now, as and when the data grows exponentially, that is where the neural networks, the deep neural network and the shallow neural networks comes into picture. And they really outperform these traditional machine learning models. And because the compute cost is going down and we have good resources to run these heavy models, I think most of the applications where we have good amount of data, people are trying out the deep learning models, the deep neural networks, right? So that is how we generally choose which models to take, which approach to take, and then based on our problem definition, we select which models to take, right? So this is a general overview of what machine learning and AI are. And I'll also talk about the evolution of the whole of this AI and machine learning beginning from 1800s, right? So in 1800s, right, we have had this linear regression which was developed by Lagrange, which is like very fundamental models which are used to predict variable and how that is varying with respect to the dependent variables on that, right? So we fit a model, and there was like a very basic models. Then in 1957, the perceptrons were invented, and these perceptrons are basically the most fundamental neural network models. Now, it really didn't pick up at that time until the late 90s because of the volume of the data was not good. The compute costs were really high. So just like a tree grows, before the tree grows, there are the roots that goes under, right? So there were a lot of developments that happened in the 90s, late 90s. For example, the back propagation happened, back propagation neural networks development happened in 1986, and then uh, many of these background work was happening. So reinforcement learning is being another one that was also a cornerstone for the neural networks, right? So these were really developing, but really not picking up until late 90s. Uh, in this period, right, from 1800s to 90s, uh, most of the machine learning algorithms were developed. Support vector machines, the KNN, K-means, all of these were developed during this, and they were really and heavily utilized for building the models. Now, in 2000s is where we have seen the drastically uh, or the leap on the neural networks and the large language models, right? So the deep convolution networks in 2012, which was developed by Alex, actually hit the market. In 2014, the GAN, or Generative Adversarial Networks, which is the foundational models for all the image classification, image generation kind of a tasks, right? So that took place. Then 2017, the transformers, that is basically the core of all the large language models like ChatGPT, like BERT, right? So this made great progress in the 20s, and now in 2020, when GPT-3 was released by OpenAI, it really shook the market. And everybody was like just trying to understand, use, and make most of it, right? What has changed from 2020 till 2024 is not just the enhancement on this GPT or the large language models, but also the introduction of the agentic AI, which is the latest, which came in like early 2024s, which are like autonomous uh, agents that can perform and make decisions and reasoning more than what the LLMs can do, right? So these are heavily utilized in replacing many of the manual tasks. So LLMs had a limitation. It used to work on a prompt basis. So you ask a question and you get a response, right? Just like a chatbot. But these agents are a leap forward. So it not just asks a question and gets the answer, it also reasons back. It also makes the decisions, and you can have like multiple agents running together to perform a whole workflow, right? So one agent talking to the other agent and doing the things, right? So that is how the industry is evolving, and I think almost every industry is now trying to utilize uh, the large language models for their data contextualization, for their data understanding, and also for building the models, right? So this is the evolution of the AI and the machine learning. And before I jump into the applications of one application of the AI and one application of the ML that we have done in our company, I would like to take a pause here and see if there is anybody who want to ask any questions, anything, what is in your mind. Okay, so maybe we'll have the question answers and discussions towards the end. So I'll move to the applications part. So yeah, you're saying something?
Yeah, actually, recently I've come across one model called Mouse. It is reported. Whatever you referred,
Yeah,
about the agents 2000 released in 2024. Do
yeah.
you really mean that Manus kind of thing which is released by China?
Sorry, I didn't get it. What is the model name?
There is a model in NUS. So it also, I mean, this is not fully understood, but it said that it gives more than it is asked actually. It calculates all aspects in the background and then give an answer which is suitable for the context or the person.
That is right. That is right. Yeah, so I have not really listed down the very recent ones. So I would say definitely there are so many different variants in the versions of the GPT, and also advanced versions of the agentic workflows are coming in. So yes, now if you look at these LLMs, right? So they had training data. They used to train on a very large data sets and then give the answers based on the prompts that you give. They used to find some questions, some answers, and then do reasoning. And they are like actually work on predicting the next sequence of the word based on the previous, right? But now what has happened is that with the current advancements, it also reasons back. It not generally only looks at the previous word and tries to predict the next word, but it also tries to understand the sentiment of the word, sentiment of the whole uh, sentence. And also on top of it, you can give your context to it, right? So I can have a model, I can give some documents and some of my previous researches and findings, and it can actually build a context around it. And when you ask a question to it, right, it will refer back to the things that you have provided, and it will first give you the response based on that. And then if you go beyond that, then it will start searching other things, what it knows, and provides the answer. So possibilities are endless. I think we are definitely moving towards making it more and more robust. Also, there are some ethical considerations when we talk about implementing or deploying these things over an industries, right? So often people ask us if we go and tell them that we want to deploy a copilot, which is basically a large language model, right? So they ask that whether my data is going to be with you or is it going to internet, right? So there are a lot of ethical considerations that comes into picture. So yeah, I will say yes, the models that you talked about, definitely they are promising and they're coming up. And I have not really listed all of the models which are like after 2024. Okay, I will move to the next slide then. Okay, so we have had two applications that I'm going to talk about today. One is the application of a machine learning, traditional machine learning, where we have done the silicon forecasting of predictions of a blast furnace. The second being use of the neural networks and anomaly detections to predict the failures in the machineries of the aluminum rolling plant, right? So let me take you to that. So as I said, silicon is a very important factor when you want to optimize the blast furnace operations. Knowing what silicon value will be there ahead of time actually helps the whole operations team to plan how they want to control the blast furnace temperatures, right? So if the silicon is low, it means maybe the blast furnace is not operating at the right conditions. That's an indicator, right? So it has a potential to tell the blast furnace conditions. So what we've done is that we used uh, the light GBM based models to predict the silicon values ahead of time. So 2 hours ahead of time. We have also tried predicting it for 4 hours ahead of time, and we actually got the 90% accuracies, right? So we did use a lot of data. We use the process data, we use the lab data, which basically involves coke ratio, hot air temperature, furnace top temperature. So these temperatures were the time series data. Then the lab data, which comes in batches, right? So these data comes in like periodically, not continuous. So it comes like every 1 hour or 2 hours. Sometimes it comes in like half an hour. It depends upon when the sampling was done. And we merged these two data and we made a light GPM train on this model. And we did the predictions for the next 30 minutes, 60 minutes, 90 and 120 minutes. And you can see here, right, the actual versus the forecasted value. And this runs on the live. So we deploy this model to our customers, to our clients. In this case, one of the leading uh, crude steel producers. So we implemented this, and they were really happy to see how these models are actually forecasting the silicon. So this is one of the applications. This just talks about a little bit in detail about what kind of feature selections we have done, right? So we did the correlation analysis to see how the silicon is correlated with the parameters that are being collected. We also did PCA, which is principal component analysis, to select which are giving the highest variations in the next silicon values or the current silicon values. That way we have done the feature selection, and then we built the model. We used different models, but then we arrived at the light GPM as one of the best out of all that. And that worked really well, and we were able to demonstrate it with a good accuracy. Now, the second use case that I'm talking about is neural network based anomaly detection engine, which is for the aluminum rolling plant. So for some of you who may not be aware of what exactly is an aluminum rolling plant, here what happens is that the recycling or the scrap remelt, uh, basically all the cans of the aluminum which were used, they goes to a furnace, and then in the furnace they are melted, and then they are casted into the ingots. These thick ingots are then passed through the reversing mill, And these reversing mills are kind of, how we make the chapatis, right? So it will basically reduce the thickness of the ingot to a required thickness. It will also be heated while doing before actually passing through this reversing mill, and that is why the hot reversing mill name comes in. And then once it is passed, it has a required grains and the thickness. It again goes to the finishing mill, which is a second pass, which is a cold pass, which gives the proper finishing based on the requirement of the customers, right? And sometimes it goes to cold mill, sometimes it gets skipped from it based on the requirement. And then, the edges are slittered because once you do the rolling, the thickness, the width of the sheet increases. So you do the slitting and the coiling and then packaging and shipping. So this is how the whole process of the aluminum rolling happens. Now, what happens is that these mills are operated 24/7, and generally they are very high throughput machines, right? So every minute of a downtime counts into dollars or rupees. So the availability of these mills are very, very important. And that is why it is important to know if there is something failing or if there is something going to fail, right? If we can predict it ahead of time, then we can plan it, the, the, the change over of that particular part, or we can repair it on time without having operational downtime, right? So that is why it is important. Now, there are so many sensors people put in when they design this whole machinery without knowing exactly how they are going to use it, right? And they come up and they think about what exactly can be done with that. So there are sensors for the process parameters. There are PLCs, and then they go to the historians. They store uh, many of these information, but they really don't know what exactly to do with it. There are the vibration sensors also that are generally placed in, right? So then once you have a good amount of data, these machine learning models can actually make uh, some good predictive models out of it. So what we have done is that we have used the neural networks to predict the failures, right? So fault coverage, if you see, we were able to predict the motor faults, bearing faults, uh, the gear issues, the spindle issues, bearing wear, and hydraulic issues, right? All of these we were able to uh, predict ahead of time using the information that is being saved on the real time and also the historical data that we have. And the impact of doing this is really, really high. If you see, we have already uh, been told that the customers or the clients to whom these models were deployed have saved more than $1 million in the maintenance just because we were able to predict these failures ahead of time. So this is my second use case. So how we have done it, right? What we generally use is called a blending of the process and the high frequency vibration data. So we not only take one data and then trend it and put some rules or run it on an anomaly detection engine. No, what we do is that we make use of all of these data process plus the vibration data. We fuse them together and then derive some important features from the vibration data. And then we train the anomaly detection engine based on different set of models, not just with one model, right? So we use KNN and autoencoders in conjunction, and then we generate a composite score, which is called anomaly score, to indicate if there is any issue. If the anomaly score is greater than a certain threshold, that is when we know, yeah, there is an issue, right? And these models not only tells that there is an issue, it also pinpoints that which of these inputs are not in the range, right? So you get to know if there is a vibration in certain asset is higher, you get to know that, okay, this is the issue which is coming is because of vibration higher on a particular asset, and then the concerned department or the person can go in and diagnose it and repair it, right? So that is how this whole AI-driven asset reliability in aluminum rolling um, plants was accomplished, and this is one of the successful applications of the AI that you can think of. So these are the two applications which I wanted to share, and I also wanted to a little bit talk about what is media talking about the AI and the machine learning, right? So if you see, many of these are trying to scare the people that this is the end of the salaried middle class, just because AI is replacing uh, most of the human tasks, right? So Google says that third of its coding is already done by AI. Similarly, I read many a times that people are having a fear of losing their jobs because AI is taking over and they need to upskill, right? So upskilling is important, definitely. But I think some of these which talks about having job loss just because AI and machine learnings are taking over is not really accurate. You can see that it is not only a downside of having these models, there are upsides of it as well in the job market, right? So over 2 millions of the AI jobs is set to boom, and this is all related to the applications of AI and ML, right? So it is also creating jobs. So I would say there is a paradigm shift which is happening. People need to uh, upskills and upgrade themselves to make use of all these AI tools. And then I think it will not only help in making the things faster, it will also help them grow in the career, right? So that is why I conclude with the takeaway that gaining the foundational understanding of AI principle and applications is very, very important. You can be in any domain. You can be in nuclear domain, you can be in pharmaceutical domain, you can be in engineering domain. Everywhere they are important. In fact, you will not believe, but some of these slides that you see, the current slide, right? This slide, I have made it with the help of an AI agent, right? So I give that I need a slide with this, and this, and it will give you the whole of this architecture. And it will not only give you one, it will give you tens and 15 and 20, and then you can go ahead and select this is what is fitting my idea and I want to put it, right? So it also improves the speed at which you can create the things, and your daily or day-to-day works can be then focused on doing what is more important, right? So adapting the AI tasks, integrating it into your daily workflows is very, very important. You can do a lot of search, in fact, a lot of writing, and a lot of search with the context is happening very, very fast with the help of these large language models. Now, we can use this not only just for our personal applications, but also for the scientific community, wherein we can, you might be listening to the news that, some of these AI models are able to predict or solve very, very complex problems, which were really hard to crack, right? So these are definitely very, very useful for doing the research as well. Once you are good at understanding, using it, I would say you can definitely contribute when it comes to participating in the AI ethical discussions, and the feedbacks can be given so that these models can be improved, right? So that is the takeaway, and I will definitely encourage uh, everyone who is listening to this talk to go and explore what is there in the artificial intelligence, uh, in the large language models, in the chat GPTs, in the BERT, right? And there actually a very, very good place to start learning as well. It is not that you need to understand the full coding, you need to understand uh, the very, very basics. You can actually go and ask every step and understand from the basics, right? So it is code in writing, generating, and reviewing, and it speeds up a lot of things. Yeah, so that is the takeaway, and I would like to thank everyone who is here to listen to my talk, and I would like to thank the placement cell for giving me this opportunity to talk about what uh, I have worked during these years, right? Yeah, so that's my presentation, which I wanted to talk, and I hope it was useful. And if there is any questions people want to talk about, I'm pretty open. One second, I'll be back. Yeah, yeah. Please tell me. Sorry, I can't hear you if you're speaking.
Only,
Yeah.
yes, I will just introduce myself. My name is Sarwar, and I'm currently working as SOD in ASL. So I work in structural domain. So I'm working on the MBA applications in structural domain. So my query was regarding your second application, regarding the analytic application. Like you have generated the data, you got the data from the sensors, and you have the trained your AI model for any anomaly detection, or like how the AI model was able to detect the anomaly.
Mhm. Okay, it's a good question. So let me answer it. So what we do is for any machines, if you see, right, when we collect the data, you will have something called a normal operating period, right? Wherein you don't observe any failures. And then you have certain periods where you see that there is something which is failing, right? The first and the most important part of this anomaly detection engines was to find out what was the normal operating or a good operating period. And we train our model based on this good operating period. That is where we get the anomaly scores which are less than 1. Now, when we feed in this data, the one that had some issues in the machines, right? And you can see this anomaly scores will start showing you higher because this anomaly score is nothing but a composite score of showing you how all of the data lies, right? So if you have any anomaly in the issue or issues in the machine, right? You're actually your parameters are actually deviating. So the distance between this normal operating region and uh, the current operating region which is having issues is higher. So you start seeing that in the anomaly scores going up, right? So we
Okay.
train the model on the good data, and then we feed in the live data or for checking what is happening.
Okay. Got it. And one more thing, where I see the anomaly detection,
Mhm.
like there's a time series data, basically it's a signal data. So you have trained your model with a multiple signal data, or like for every one signal, you have trained only one.
No, so we use the time series for time series data, and we actually do feature engineering. We
Okay.
kind of we kind of a downsample it to make sure that we are taking a sufficiently longer period, right? So if we are we have to have a good model, we need to have at least 3 to 4 months of good data sampled at every minute so that our models can learn. Because these models will be accurate if you have a good amount of data. If you are training it in a very short data, you might be overfitting.
Okay. And I have one more question not related to the projects. I just want to know the implications or kind of of pins, like physics inspired neural networks, which are kind of, there's a lot of buzz going around about the pins, like they are kind of alternative to the finite element method. So, like, I want to know the applications of that in the industry domain, since you work in the industry, work in the industry. So, I just want to know, is there any applications to the pins in the industry?
I couldn't hear you very clearly, so I
One
could
second, I
understand.
will just say my entire question. I have a doubt regarding pin. It's physics inspired neural networks. There is a one word about this one as they are termed as alternative to the finite element method.
Mhm.
I just want to know the implication of the usage of the pins in the industry.
Mhm. Okay. So yeah, I agree. So some of the models which are like basic or the fundamental models, for example, let's say if we talk about finite element models, right? So I don't think so any AI or machine learning can actually replace those fundamental models, but where exactly it can help is to provide you the information that what kind of meshings you need to do. If a new user is there who want to understand that what is the best setting for this kind of application, right? So they can get a lot of insights from that. They can do kind of a design of experiments, or they can also get some understanding of what exactly works better in this kind of a settings, right? And once you have that thing, the design of experiments set up to run these different FEM models, right? Then you have a good amount of data that you can use for making a simpler model, maybe a linear regression model, or maybe a nonlinear regression model that will give you a model which will be able to predict when you have not even run the FEM, and then you can tell that, okay, this is the value that I should be getting. Maybe if you're talking about a stress, right? So you can tell, okay, this will be a stress for these conditions because I have run the kind of experiments. I now have a simple machine learning model which is based on the actual simulations.
Understood. Thanks a lot.
Yeah.
Hello. Yeah.
I am Piyush Kumar from ANCT. My question is about the second project you have told.
Yeah.
So there is an anomaly score you are getting, but how do you know where is the error in the motor or in the something gear, or as you told, you pinpointed where is the error so maintenance can be done. So how do you come to know from anomaly score?
Yeah, right. So what approach we take, right? So if we have to, let's say, make a model for a, we don't make it at a plant level one model. First thing we do is we make a model at a system level or an asset level, right? So we will break it down into 10 models or 20 models. So for, let's say, we will have one model for pump, one model for compressor, one model for gearbox, right? And that way, and each of these models will have all the parameters that are related to that particular subsystem. And then you will get an anomaly score. When the anomaly scores are higher than the threshold limits, we also get to know what are the factors because of which the anomaly scores are getting higher, right? And that way you can tell that, okay, issue is in the maybe input side of the gear or the output side of the gear or in the bearings, something like that.
So do you have different anomaly score for different parts, or based
Yeah.
on the features you
Yes.
get
Yeah.
here?
Yeah. So we have one anomaly score per asset. So motor will have one anomaly score, gearbox will have one anomaly score, pumps will have another anomaly score, something like this.
Thank you.
There is one question in online. Just wait. There is from Chandan from GCC. Can you see the message in the chat box?
Yeah, I am reading it. So the question from Chandan is, I have a question that which machine learning tools one should learn, which are extensively used in the industries, as there are many different academia and industries, right? I think what I will say is that you need to understand the basics of or the basic principles of the machine learning, right? So any model if you take, right, you don't need to understand the whole what you say in and out of how the model was built, but you need to understand the basic principle of how do I prepare the data, how do I train the model, what are the scores I need to check when a model is trained, what are the elements that I need to see if the model has trained well or not, right? Once you understand this, then I think the second thing is to understand the model itself, right? So if you understand the whole process, you don't really need to learn or master every model. You have to run multiple models. There is no alternative, right? So there is not one size fits all in any situations. You have to have multiple models tested, and then only you can say that okay, this model is outperforming or performing the way I want it, and then I will use it, right? So that is how it goes.
Thank you, Amit. Here is any other question in online or offline?
Hello, Amit. Sai here. Oscar. And I just want to know, like, what is the role of the AI in the business environment? Like, especially if it's related to, I've seen your profile, you work for Airbus. Like, is it too technical or is it too business oriented, like applications or both?
So if I talk about the industrial applications, right, they are definitely very technical. But then there are non-technical applications, but I don't think so that are really going to be very useful. They are more like, people trying to simplify their job, right? So if you talk about technical, we have had uh, multiple machine learning models which were trying to predict different things. One example was trying to predict the tire pressures of an aircraft, right? So that once the landing happens of an aircraft, the tire pressures actually significantly change, because these are not just like the normal uh, my daughter has switched off the light. Okay, these are not just the normal. So when you land, there is a huge amount of energy that dissipates through the brakes and through the ground friction, and that's where the tire pressure changes. And the tire pressures are very important for the next takeoff, right? So it all translates into the dollars and the numbers if your takeoffs are not happening on time, right? So predicting that on what kind of conditions you should land, how much brake should be applied, how many turns it is going to take. That is very important. So these are very technical models, and I think that is where most of the value lies. You need to focus on the technical models. Non-technical models are like talent acquisition team trying to find a resume of a candidate who is fit for this job, right? They're just trying to eliminate some of their manual tasks. Maybe they will eliminate their manual task of screening 1,000 resumes for a good job.
Okay. And so actually, I have seen your profile here. You just explained a example, a bus regarding it is entirely mission oriented. Are there any applications regarding the mechanics oriented, regarding structural mechanics oriented applications of AI?
There are multiple. There are many actually. There are many, but I don't recall working on mechanical part. I have actually worked on the electrical domain of the Airbus there. I worked on the landing gear side, but there are applications related to the structurals as well.
Thank you.
And one question that what language that you use, or Python or any? Yeah.
Python, yeah.
Mostly
So
Python.
yeah. I believe for data science, Python is the most important language that you should focus.
And this this is the AI tools which is available in it, or anything to especially model the techniques.
So I think for running the Python, you can use either PyCharm or maybe there are Anaconda. These are some of the free applications. They are good enough to train, I would say, not just the machine learning models, but also the deep learning models as well.
Okay. Also, you use PCA, I saw the mentioning. So you use NN network, neural network with PCA, or the PCA also is separate?
Sorry, ma'am, I didn't get your question. Can you repeat?
You use PC also with the physical component analysis.
Yes, yeah.
So that you use separately, or as part of your package?
Yeah, it is also part of package I've used. Yeah, part of package.
Okay, any other question in online? No. Chat box? Anything in question? So any question here? So if not, then we thank Amit and for this wonderful talk, and I'm sure the students will be very much benefited by this talk. And regarding the also for placement, so I would suggest the Amit would help all the students in this AI field. What are the different career opportunities that there in India and abroad, so that we can give some information regarding that. So, and your email, shall I also can be seen in the description box in the YouTube,
Yeah, sure.
so that people can contact you. So, okay. So, thank you very much, and for your insightful talk. Thanks to all the participants here, and all the people present online also. Thanks the IT team for making this online term possible. Thanks all. Wish you all the best. Thanks.
Thank you. Thank you, everyone. Have a good day.